All right, folks, we are going to go on to the second part of 5.4 today. That is 5.4b, operations with complex numbers. So we are going to jump right in. I'm going to start doing some examples right off the bat. The directions are going to be simple, and no pun intended, because it's going to tell you simplify. So when they tell us simplify, they're going to give us something like this. And these are when we say operations on with complex numbers. I'm going back to what I said in 5.3 or 5.4a, where we talked about a plus bi type of form. All right, so you could have something like this. You could have negative 4 plus 2i plus 6 minus 3i. So again, this is your first example, and they're asking you to simplify. All right. If we have this, we've got a complex number here, real component, imaginary component, real component, imaginary component. So these are both a plus or minus bi form, right? So how do we do that? Again, the same thing we did where we solved at the end, where we solved where real has to equal real and imaginary has to equal imaginary. What we're going to do here is we're going to add the like components. So negative 4 plus 6. We take this plus 6. So negative 4 plus 6 equals a positive 2. Then we do this piece and this piece, again, adding them. So 2i plus a negative 3i. So 2 plus a negative 3 is negative 1. So that is just negative I. And we are done. We have our complex solution in a plus bi form, a plus or minus bi form, in this case, a minus bi. All right. So again, just a basic example. Let's do another one. Another example is, let's do this one. 5 minus I minus 3 minus 2i. So now, again, we're going to look at this as a operation is subtraction of two complex numbers. So 5 minus 3 is equal to 2. Negative I minus a negative. So this becomes plus a positive 2i. So negative 1i plus 2i is a positive I. And we end up with 2 plus I here. All right, again, some basic examples, just adding or subtracting complex numbers. Now, let's keep going. Again, directions are still simplify. All right, and now we're going to look at multiplication. If I have this, 5 minus 2i times 4 minus I. All right, so I have this. Doing this one. This is just like having, anytime you had a plus b times c plus d, you just did FOIL, right? First, outer, inner, and last. Same idea here. These are just components. So we have a binomial, so to speak, with a complex number, because we got two pieces times two pieces. So we're going to distribute it however you want to think of it. I'm going to multiply this times that and this times that. And then the same thing with the second part. So first would be these two. 4 times 5 is 20. Outer would be these two. 5 times a negative I. That's a negative 5i. Inner, negative 2i times 4 is a negative 8i. Again, 2 times 4 is 8, and we have the I there. And then last, negative times a negative make a positive. It's 2i times I. So that's 2i squared. Now, what I want you to remember is, what is this really saying? What is 2i squared? 2 times I squared, right? Well, I squared is equal to negative 1. So this is saying 2 times negative 1, which is equal to negative 2. So you don't have to write this step necessarily, but you have to recognize this is 20 minus 5i minus 8i minus 2. That's what this 2i squared translates, the plus 2i squared translate into a negative 2, or subtract 2. And now we add like components. I have a real number and a real number. 20 and negative 2 make 18. And then I go to these, negative 5i and negative 8i. Together, they make a negative 13i, right? Because I had negative 5 of these, and I subtracted 8 of these I. And so we get negative 13i. All right, that would be our simplified version. Let's do another one of these. That was example 3. Let's do another one. Next example. Example 4 is, let's see, let's do this one. 4 minus 2i times 3 plus 2i. All right. So again, we've got multiplication of two complex numbers, right? They have a real component and an imaginary component. So I'm just going to do my FOIL again, or distributive property. 4 times 3 is 12. 4 times, or positive 4 times a positive 2i is a positive 8i. If you're wondering what I'm doing there, when I say 4 times 2i, what I'm really saying is 4 times 2 times I, just to be clear there. So these two multiply to give me 8, and I still have that I. That's how I get positive 8i. All right, just to be clear on that. And here, same idea. I've got negative 2 times I times 3. So I can do negative 2 times 3 first, and I get a negative 6, and then I have an I. This again, we're doing negative 2 times I, and then times a positive 2 times I. These numbers combine to give me a negative 4. These two things combine to give me I squared. So this is negative 4 times negative 1, because that's what I squared is. I squared is negative 1. So that gives me a positive 4. So I'm going to put plus 4. All right, and we can go from there. 12 and 4, we're going to add the real numbers. The real numbers give me 16. And then I add the imaginary portion. 8 minus 6 gives me 2, positive 2. And then those are i's, right? And we have that one done. All right. So, again, I would suggest maybe if you're struggling with this, write these problems down on a separate piece of paper and do them, kind of just pause the video here for a second and do those again on your own. Look away from the screen, close it down for a minute, minimize it, whatever, and try to do those same two problems on your own. See if you can get the same answer. All right, that's what I would suggest. So just to see if you got it clear what we're doing. All right. The last type is going to be simplifying a rational expression. All right, so when we talk about this, again, it's going to be simplify. And they're going to give you rational expressions. So for example, something relatively straightforward. 7 minus 13i over 2i. Now, you may say, well, what do I need to simplify this for? We can't have imaginary numbers in denominators. All right, we can have in the numerator. It's just like radicals. Remember, we had to always get a radical out of there? Well, we got to get the I out of there. And we do it much the same way. Remember, if I had, say, 2 over root 3, I multiplied top and bottom by root 3 because I wanted to make it into a number. So this became 2 root 3 over 3, right? Same idea here. I want to get rid of this I in the bottom. So if I multiply I times another I get I squared, which is negative 1. So I can do it in a basic sense just by multiplying it. Again, I have to do it top and bottom, so I'm not changing the number. This is 1 because it's I over I is 1. But I can multiply this, and when I do that, this I just gets distributed through here. So I would have 7i minus 13i. I'm just getting a little lag here. 13i squared. All right, it did not like me doing that. Okay, and now 2i times I is 2i squared. But what is 2i squared? 2 times I squared is 2 times negative 1. So that would become 7i minus, well, let's do this one too. That is a negative 13 times I squared. So that's negative 13 times negative 1. So that actually becomes a positive 13 on top because that was 13i squared. So it becomes, I should say, negative 13i squared is now positive 13. This is negative 13 times negative 1. And on the bottom, we get a negative 2. And we'd be done. Now, your book may take something like this. There are people that don't like to leave a negative in the denominator, and they may divide everything by negative 1, so you'd end up with negative. And again, you know what, actually, let me also say one thing. Let's not accept this right now. I usually wait a little bit to bring this up, but let's just do this in a good form. We may as well do this right now. So when you have this, this is not fully simplified because two things. One, this is in the wrong order. So we want to write that in the correct order where we have our real component, then our imaginary component, and then the negative 2. I would accept this right now. I would not accept this. I don't want it in this order. I want you to put these in the right order, the A plus BI order. I want you to get used to that for a complex number. Now, the one thing is, like I said, the book made negative 13 minus 7i over a positive 2. And I would accept that as well, just dividing that negative through the top. I don't care which one of these you use. I think this is just as useful as this. So either one of these would be acceptable. All right, let's do another one of those. Let's do, let's say 3 minus 4i over, let's do 7i. All right, and well, you know what, let's make it even better. Let's make this 2i again. We had it before, let's just leave it as that, 2i. All right, so with this one, again, asked to simplify, we could multiply top and bottom by I. When we do that, we're going to distribute it through here. So we'd get 3i, and again, this is negative 4i times I. So negative 4 times I is negative 4 times this is negative 1, or I squared being negative 1. So this is plus 4. And then over here, this is 2i squared. Again, 2i squared is negative 2 for the same reasons as last time, because that's 2 times the negative 1, right? I squared. So now we have, again, 4 plus 3i, writing it in the correct order, over negative 2. Or you could write this as 4 plus 3i over, I'm sorry, I lost my train of thought there. You could write this as negative 4 minus 3i over 2. Good. All right, so again, one of those things we can do. All right, let's go to the last type. And this is one, these are the type that sometimes give people some troubles. This is still simplify. And it still needs to be simplified for the same reason. You're going to be given another example like this, where we have, let's say, 3 over 4 plus I. We have an I in the denominator again. Not something we can have, not something we can live with, but we've got, it's kind of hard to think of how are we going to get rid of this? Because if I just multiply by I, think of what happens. If I multiply top and bottom by I get 3i on top, and on the bottom I get 4i plus I squared. So that would be what? I, and then 4i minus 1. I didn't get rid of the I still got an I in here. So this is not going to work. We can't do that. We can't just get rid of it that way. And this is where a word that's going to come up, and we've already talked once about it this year, but it's going to continually come up. If you're given this, you have to look at this bottom. And in order to get rid of this, we have to multiply by the conjugate. Remember, the conjugate was that other piece. If you had A plus B, the conjugate would be A minus B. And the reason is it's called a conjugate, a multiplicative conjugate, because if I multiply these two, I get A squared minus B squared. All right. If you had A minus B, A plus B would be the conjugate. So these are conjugates of one another. So in other words, what I have here is 4 plus I. The conjugate would be 4 minus I. We just change the sign between, and I have to do that top and bottom. I have to multiply these. Okay? So doing the same thing, just a little more complex. So 3 times this would be 12 minus 3i on top. On the bottom now we got to do what we did in that last set of problems, not the immediately previous set, but the set before that where we had multiplication. I got to multiply first, and I'll have 16. Then outer is a negative 4i. Inner is a positive 4i. And then last is a negative I squared. So we have this. Now, what you notice here, I hope you notice, these cancel. And that was the whole idea. For those who are saying, well, I still am getting i's in the denominator, you're not, because these are going to cancel each other. That was the whole idea. When we had a plus b times a minus b, that's why we chose the conjugate. What happens is you get a squared minus ab plus ab minus b squared. So these things are always going to cancel out. That's why we use conjugates, because you just end up with a squared minus b squared. So in the future, if you want to ignore these middle ones, you don't really have to write them in there. You could just say this is going to be 16. Positive and negative is always going to give me a negative, and then this thing squared, negative I squared. So this becomes 12 minus 12 minus 3i over 16 minus I squared. That's plus 1, because that's minus negative 1. I squared is negative 1. So, need a little more room. This is going to become 12 minus 3i all over 17. We've eliminated any i's in the denominator, and we are good to go. That is our solution. Okay? Let's do one more of those. Again, I suggest you try doing this on your own. When you see me go through this, following along and taking notes as you go is great, but also pausing this video. It's one of the advantages we have of having a video lesson. You can pause this thing right now and try to do this one on your own. Go back, write out just this problem, the original part, 3 over 4 plus I, and see if you can do the same thing I just did. If you can't, then open it back up and look at it. Go back and forth until you can do this independently. Let's do one more. All right. Let's do 2. Let's see, over 4 minus 3i. Okay, so now, again, we're simplifying. We got an I in the denominator. Don't like it, don't want it, got to get rid of it. So the way we get rid of it is multiply by the conjugate. So again, because this has 2 terms here, we're going to do 4 plus 3i, and we have to do that top and bottom. And when we do that, we get on top, we're going to distribute. So we get 8 plus 6i. All right, 8 plus 6i on the bottom. Again, remember, if you remember, all I have to do is this, 16, and then this. Now this is going to be negative 3 times I times 3 times I. So these two make a negative 9. This makes I, these two make I squared. So this is negative 9 times negative 1. So this is 16 plus 9. And when we have that, we get 8 plus 6i over 17. 25. I just totally gapped there, guys. And I'm not going to take it out of the video. I am going to leave it there, warts and all. So over 25. No common terms, so we are completely simplified there. All right, again, if you look back at this one, same idea, right? We ended up with just the outer and inner. That's what I want to make sure you understand is we just had to do outer, I should say first and last. We got rid of outer and inner, and we get our solution. All right, distribute the top. And that's all we're doing. We're doing a lot of these. We're just going to simplify, simplify, simplify. So you're going to get a bunch of these. just so you don't freak out, I'll do one that is the ultra hard. If you had something like 2 plus I over, let's say 3 minus 2I, what do we do here? Same idea. One last bonus example. Multiply by the conjugate. And when we do that on top, we're going to do all of them. 2 times 3 is a positive 6. 2 times 2I is plus 4I. I times 3 is a positive 3I. I times 2I is a positive 2I squared. All over. Now on the bottom, we're using conjugates, so we just have to do the 2. 9, and this is minus 4I squared. That's plus 4, right? Minus 4I squared equals a positive 4. Because I squared is negative 1 times negative 4. So what do we got here? Well, think about this. This 2I squared, what is that really? 2I squared, it's a positive 2I squared really means negative 2, doesn't it? Because 2 times negative 1 is going to be a negative 2. So what we're going to have is 6 minus 2, that's 4. And then we got 4I plus 3I, that's 7I, all over 13. And we are good. Again, nothing too extreme, just had to multiply a binomial on top, or a pair of binomials on top. All right, that's it. This time I promise, that's the end. All right, that's all we're doing for 5-4B. Have at it, and I will see you tomorrow to answer any questions, guys. Have a wonderful day.